Hello, everyone. So my name is Christian. I work in Water Services and Technologies with Jefferson. We will be presenting you today this webinar in partnership with Waterloo Hydrogeologic. I can see Saber is on the beach there. No? Okay. It's a nice place to be. So let's start. And as I'm going to go through the presentation, if you have any questions, please feel free to interrupt me and ask any questions you want, okay? And you can also send the questions on the chat here, or you can open your microphone if you want. So let's start. So today our webinar will be about the HGA GeoAnalyst, the software that was developed. This software was developed by Waterloo Hydrogeologic. So our agenda for today will be, I'll just give you a brief introduction on the subject of data management. And then I'm going to show you some data management challenges that we see that our clients deal with on a daily basis when they don't have this a proper data management. I'm also going to talk to you about some basic concepts on data management, and then I'm going to show you a simple step-by-step steps to implement an integrated database if you want to. And then I'm going to talk to you about GeoAnalyst, HGA. I think it's important to have all this introduction, these 4 topics before going to HGA, because it's important to know the basic concepts on data management and why is it important to have a good data management. And then I think it's a good idea to talk about HGA. And then I'm going to talk to you some report possibilities that we can have after we have this data management. And I'm also going to show you some practical examples using HGA and why is it so good to have this database, integrated database on our company, and why is it so, why is HGA the software that we use for data management here. And the objective of this webinar today is to convince you that integrated database is essential for the quality and efficiency of hydrogeological and environmental projects. So, introduction. First, I'm going to talk about the difference between data, information, knowledge, and idea. So data is a number, a text, or a measurement. It's something that by itself doesn't send us any message. So I just have a number there. It's not showing me anything. It's just the number. So it's just the measurement there. And then I have the information. And the information I get after I study the data that I have. So I get the information by analyzing the data that I have. And after that, well, we can have this information and we can interpret our data. We can make decisions. And the knowledge we get when we use all the information we have to take decisions. That's when we get the knowledge. It's when we create a relation between all the information that we have to take some decisions. And then we get the knowledge, we get to know our environment or the company we work on or the environment where we are working on. You know, that's where I get the knowledge after I study my data, get the information, and then I get the knowledge. And the idea we get when we build a connection between all the information that we got. So for example, we can get different ideas about our flow rates when we analyze our groundwater level, our lithology profile, our aquifer characteristics, or our soil characteristics. And then I can get some ideas about, oh, why is my flow rate so high or so low? Why is it happening? Why is this happening here in my borehole? What's happening here? So I can get all this idea after I study my data, I have the information, I have the knowledge. And business intelligence is something that we are hearing much more every day. It's when we get from the data straight to the idea. So we don't have to manage our data, organize everything, and then get the information, and then take the decision. So business intelligence is here to help us to get straight from the number to the idea. So, and then we can save time on managing data, and then we can have more time to analyze our information and then take the right decisions. And as time passes, we have much more data available. Wherever we work, we know that as time passes, we have the data volume just grows. And also the time available for decision making decreases at an accelerating rate. So sometimes we need to take some decision in the next hour. Like there's something happened and we need to take a decision. And if we don't have the right information in our hands or the right data in our hands, we can take the wrong decision. So that's why it's so important to have the idea or the information easily in front of us to take the right decision. And if we have to spend time managing data, it's going to be less time to study the data. And this leads us to the industry, to the so-called Industry 4.0. And in the Industry 4.0 is where the data management is it's an important issue. It's very important to have a good data management. It's in the industry of the future. So then now let's talk a little bit about data management. So we'll take just as an example, data that we have for water wells. So we can have operational data, and we can have a lot of different data. We can have groundwater level, we can have drilling information, lithology profile, physical chemical analysis, aquifer tests, elevation data history, pumping flow rate. So we can have, and much more. We can have a lot of different informations on water wells. And also related to water wells, we have some environmental data. For example, precipitation, soil characteristics, aquifer characteristics, and all these data then we can have them in a lot of different formats. For example, PDFs, Excel files. If we have some divers that get some information on our wells, we have a different kind of information, and text files. So we can have a lot of different informations in a lot of different extensions or different types of data. And all these different data, they are related somehow. We can make some connections between these different kind of data. So for example, pumping rate, the pumping flow rate depends on the groundwater level, and also depends on the precipitation, and also depends on the aquifer characteristics, and so on. We can have a lot of relationships between the different data that we have here. And that's why it's so important to have the data management. So now I'm going to talk to you about the data management challenges that we deal with every day if we don't have a good data management system. So first of all, where's the data I want? This is something that bothers a lot of people. Like, oh, I need some water level information on this borehole here from 2019. Where is this data? Oh, in which computer is the data, or with who is the data? So like if I have like all these folders here, how can I know where it is? And sometimes we don't even have these folders. Sometimes we have just a bunch of papers in the office. So sometimes it's very hard. A lot of times it's very hard to know where the data is. And also, with whom is the data? Is it with my neighbor? Is it with someone else? Is it with another office? Is the person that has this data, is he or she on vacation? Or is he not working today? And how can I get in contact with this person to get the data I want? Sometimes it's hard to find the data because we don't know with whom is the data, or the person is not available at that moment. Also very important, which format. Is the data in a PDF, in a text file, in an Excel file? And that's something very important, because if it's in a format not easily manageable, like in a PDF. We have like sometimes to manually type all the data that it's in our PDF, in our Excel file, and then we have to make all the dashboards or charts and tables, whatever we want to get some information. And many times we spend a lot of time on doing this, managing data, because the data is not in the format that we need. Also very important, which units of measurement is our data? Is it meter or centimeter? Is it cubic meters or liters? And this happens a lot. Like many times we get some Excel files from our clients and we just see the numbers, but we don't know in which unit it is. Like for volume or pumping rate, we just have the number 100, but is it 100 liters or 100 cubic meters? And this is very important to know because it can change a lot the information that we get. And also very important, does one unique point have many different names? Like in this example here, it's a borehole called number 3 on the pit X. And it can have many different names, like with underline, with dash, with spaces, or everything together. Or sometimes, it changed the number last year because we remanaged everything and the borehole changed its number. Now it's called 15, but we have like 10 different Excel files, and each Excel file has a different name for the same point. So it happens a lot. And then sometimes we think they are two different points, but they are actually the same point, just with a different name. So all these points that I showed you, they are challenges that we see a lot on our clients. And so how can we deal with this? What can we do to solve all these challenges or all these problems? So first, I'm going to show you some basic concepts on data management. So the traditional way on data management, so we have unconnected database. So we have a file for well profile. We have another file for aquifer tests. We have another file for pumping rate, or another file for water level. So we have different files, and they don't talk to each other. They are separate, sometimes in different computers. And so we cannot have we don't see the relation between all this information. And there's no standardization, because I call that point, for example, borehole 3, but my colleague can call it borehole 03 or whatever. So it doesn't have any standard. Data is unreliable. We can have some redundant data, and the storage can be in many different formats, like Excel files or text files. And this leads us to more time spent organizing data, less time for data interpretation, because if we have to spend 4 hours managing our data, it's 4 hours that we didn't spend interpreting our data or information. And this increases the probability of errors due to the lack of information control, especially when we are manually doing something or typing data. Sometimes it's easy, like the number 9 is above number 6 in my keyboard. Sometimes my finger can go a little bit up and then type 9 instead of 6, for example. So when we deal manually with data, it's a danger to get some errors. And when we talk about data management systems, we are talking about integrated database. And what's an integrated database? It's a central database, it's a central repository where all the data is. So, my water level, my lithology information, well information, aquifer tests, or any information that I need, they're all in the same central repository, in the same database. And so everybody knows where to find the data. And the data is available to use in multiple projects. And it's accessible on a network, so you don't have that problem that, in which computer is the data, with whom is the data? No, everybody knows that it's in this central database, and everybody knows how to get the data. And it usually have a quality control on the data also. So we don't have duplicate data, we don't have redundant data. We don't, and we have a standard. So that point, bar hole 03 is always called bar hole 03. We don't have different mistypes or dash or whatever different in the name of our point. And this leads us to it facilitates the data visualization, because we can have the possibility of report automation. And later today, I'm going to show you some examples on this, a report automation, some practical example. And we also have information security for example, in the traditional way, the data could be in my computer, and it could happen that my computer can crash, and then I have to format my computer, and then I'm going to lose all the data I have in my computer, and all the data that was with me, it gets lost. If we have an integrated and central database, if it's in a server, we have a security that this is not going to happen. So if my computer crashes, it's okay. Like, the information is in the central database, it's not in my computer. I will have only the problem to install all the programs again, but I know that the data that I use, it's in a central database. And why do we have to choose integrated data management? Why is it so important? Because we are dealing with a large amount of data in many different formats: Excel, PDF, Word, images, and sometimes we work in multiple projects, and we have some constant changes. And integration of data and we have integration of data from different phases of a project. And we have also system expansion, for example, new operations, new types of information. So the volume of data is always increasing. So if we work with the traditional way, it's easy to lose some data, to lose information. Also, for structuring, organizing, and analyzing data, we can establish some standards based on specificities of our jobs. And also we can have some integrated analysis of information, have some integrated reports or dashboards integrated with the database. And this helps us a lot to interpret or to get some information, to get the information that we need. Because we can have like all these different formats for reports for managers or for environmental agencies. So for example, if I have like every month, I have to send a specific report to an environmental agency with these specific dashboards or graphs or charts. If we have an integrated database, we can automate our reports. So I just have to put the new data in the database, and the report will be done because it's integrated with the database. If I open my report, the chart will be updated with the data from last month or last week, from whenever I imported the data. And this saves us a lot of time. Oh, and also we can get some different levels of data access of our permission. So for example, some people can have access to edit data, and some people can have access only to read the data. And so we can have like all these different permissions to people. And another concept that is important to know is relational database. What's a relational database? So for example, in our database, we have different tables. We have a table for drilling data, for registration data, for lithology profile, flow rate data, and for groundwater level. And these tables by themselves, they are alone, they only work with themselves. We can relate all these tables, but in a relational database, we can make a connection between all these tables because they have something in common, which is the well name. So the borehole, so we can have information on drilling data for the borehole number 3. We can have its registration data like coordinates and elevation. We can have its lithology profile, its flow rate, groundwater level. So we can have a lot of different informations for the same point in different tables. And with a relational database, it allows us to make this connection between the different tables. And as an example of relational database, the most famous ones are Oracle and SQL Server. and they use SQL language, and they have data security, permission rules for different user groups, and possibility of software integrations for automated report. And HGA, GeoAnalyst, uses the Microsoft SQL Server. Another very important concept is primary keys. So a primary key guarantee unique values in our tables. So primary keys cannot have null values. They consist of one or a single or multiple columns, and you cannot have primary keys with the same data. So what this means? That, for example, registration data, I cannot have two wells with the same name. So if I have borehole number 3, I will have only one borehole number 3. I cannot have two boreholes number 3. So our primary key on this table would be the well name, because this will guarantee that. So the database will know that, okay, now I know that I cannot have two well names with the same name. And for example, drilling data for a specific borehole from one depth to another, I can have only one diameter. I cannot have two. I cannot have like for two different diameters for the same depth, or water level for the same date and time. So let's say for September 8th at 12 o'clock, I can have only one measurement for this borehole. I cannot have two different measurements for the same date and time. So our primary keys would be well name and date and time. And in this way, the database will know that, okay, now I know that I cannot have two different informations for the same date and time for the same borehole that I'm studying. So in this example here on the screen, I would have these primary keys for the tables that I'm showing. And for the example of flow rate data, so let's see on this table here, I have here the well name PR01, date time January 1st at 12 o'clock. I have two different flow rates. So this is incorrect. The database would not allow us to import this data. We would try to import the data in the database, and it would tell us, no, you cannot import this data because you have two different measurements for the same date and time. So, and for the last two data here, it's okay. I have the same flow rate, but that's okay. I can have the same flow rate for a different date and time. It's okay. So the database will allow us to import these two last lines here, but the two first lines here, the database will not allow us because our primary keys are well name and date and time. And we cannot have two information with two primary keys in the same table. So I have here PR01 for January 1st at 12 twice. And the database will not allow us to do this. And so back for the relational database, another big benefit of this is that it facilitates the search for different information contained in different tables. So for example, if I want a table with a well name, its coordinates, date and time, and groundwater level elevation. But I only want this information for a specific geologic information. So if you see here, I want information from 3 different tables. And in a relational database, I can do this very easily. I'm going to show you an example using HGA later. So for example, in this example here, if I tell the database that I want this information, it would give me this table here. So you see, I have the well name, it's the coordinates, date and time, the groundwater elevation for a specific geologic formation. Now, how can I implement it into an integrated database in my whatever I work? So I'm just going to show a little step by step to implement an integrated database. So first step would be understanding our data. The second step would be establishing our table structure. The third step would be data standardization. So to set some standards for our data. The next step would be validation and in data import to our database. And then we can finally do the analysis and visualization of our data and finally get to the business intelligence. So I'm going to talk a little bit about all these steps here. So first, it's very important to understand the data that we are working with. So this is the step one, understanding the data. So if I'm working, for example, with this operational data, I know that I have a table with groundwater level information. I have a table with lithology profile. I have a table with precipitation. I have another table with soil characteristics. So I have a lot of different tables with all these data. And it's very important for me to really understand all the data that I'm working with. And then we can get to the second step, which is the table structure. So now that I know the data that I'm working with, I can tell the database which tables that I want to have in my database and what columns I want in each table. So for example, for registration data, I want well name, the coordinates, elevation, TOC, total depth, aquifer, and record date. And for lithology data, I want the well information. I want the depth of the information from and to. I want the lithology, description, color, geologic information, and so on. For each table, each data table, I'm going to set the different columns that I want for each table. So for example, for construction data, for drilling data, I have the drilling information, casing information for my wells. I have screen information, annular fill. And I could have a lot of other examples of tables. I have ceiling information, TOC history. So if I work in a pit, for example, sometimes I can have a history of elevation for the TOC of the well that I'm working with. So elevation history, flow rate, volume, groundwater level, and so on. I could have a lot of different tables with different data, and then I have to set all the columns that I want for each table. And also very important, I have to set which will be the primary keys for each table that I'm putting in the database. So for example, here we can see, and then here we need to create a relation between all these tables that we want to create. And as we saw before here, each table has the same one similar column, which is the station name. So all these tables, we have this same column, station name. So we can build the relation between all our tables using this column here called station name. And this is where we are going to have the relational database. This is where we are going to relate all the tables in our database. And the next step, after we have the table structure, we need to establish some standards for our data. And this is a very, very important step. So it is first, it's recommended to set some standards for a point or station nomenclature. For example, it's very common to find names like this, P1, P2, P3, PM1, and just a number, 12501. So it's very common to find this kind of simple letters or numbers. And it's important to establish a standard of abbreviations according, for example, to the type of points. For example, piezometers, we can have PZ, and bar holes, we can have BH, and so on. And to avoid the duplication of nomenclature, we can choose some abbreviations on locations too. So for example, if I work in a mining company that has some operations in different locations, I don't want in my database 2 points called P1, because I might have a P1 in my location in Waterloo, and I could have a P1 in Ontario and a P1 in Vancouver too. So it's a good idea, for example, to choose some abbreviations according to the location for my point. So in this example here, I would have WM for Waterloo Mine, OM for Ontario Mine, and VM for Vancouver Mine. And in this example, for this piezometers, I would have this nomenclature here, and I can just by seeing the name, I can say that this is the piezometer number 2 from the Waterloo Mine. I can see that this is the piezometer number 8 from the Ontario Mine. So it helps us to identify the points when we have these standards on the nomenclature. So you can see that it's a lot different from the example before. Like for just this number, doesn't tell me anything like P1, but it's P1 from Waterloo, Ontario, or Vancouver. We don't know. And if we see here, it's easy, comes to our mind like, oh, this piezometer is from Waterloo. Another thing, very important, it's very important to have pre-established lists of values. So for example, station type, lithology, or parameter. Dissolved oxygen, for example, I can call in some table, I could call it dissolved oxygen, or I can abbreviate it like this, oxygen, or D-oxygen, or DO, or dissolved oxygen. So I can have a lot of different ways to write one simple parameter, or one simple station type, like pumping well, I can abbreviate it. I can have a PW or pumping W, pumping on the line well, pumping dash well. So I can have a lot of ways to write the same thing. So it's very important to establish some list of values. So now in my database, pumping well will always be called pumping well, like the first line here. It will not allow me to put any data writing like pumping underline well. Same for the parameter. I want to write DO for dissolved oxygen. I want an abbreviation. I don't want to write it the whole thing. I want to have the abbreviation. So it's very important to establish this list of values. And it's also essential to set standards for units of measurement. So for example, flow rate, it could be cubic meters per second, per hour, liters per second. So I have to establish now in my database, flow rate will always have cubic meters per hour. This is the pattern for my database. And this is important because whenever we open a table in our database, I will know that that number is cubic meters per hour. I won't have like the question, oh, what's the unit of this flow rate? I don't know. No, I will have that information. And the database, and once we're going to import the data in the database, knowing that the pattern is cubic meters per hour. And why is it important? For example, benzene in the EPA, the maximum value is 0.39 microgram per liter. But let's say that I didn't establish any standards for units, and I put in my database the number 0.3. But I didn't know, but I just know that it's 0.3. I don't know if it's milligrams or micrograms. I see the number 0.3 and I think, oh, it might be micrograms. So I'm okay, I'm good. I'm under the maximum limit. But no, actually the unit was milligram per liter. And this means that in the database, I should have written 300 micrograms, which is much higher than the limit from EPA. So this is just an example on why is it so important to have standards on units, because we can make big mistakes if we don't have a pattern for units. Same for groundwater level. So for example, I can have 150, that could be meters, and that's what does it mean? Is it elevation? Is it depth? Or what's this number mean? So it's very important to set these standards. And also, is it 150 centimeters or meter or 15 meters? So it's very important to have this. Also, pay attention on the date format and decimal separator. And so, for example, this date here, is it the 1st of February or is it the 2nd of January? Like, so because in the US, we write the month first, so it's gonna be 2nd of January 2020. But here in Brazil, we write the day first and then the month. So for us, this would be 1st of February. So it depends on the region that we are. The date has a different format, so it's very important to set a pattern for date format. Oh, it's day and then month and then year, or no, it's month and then day and then year. So it's important to have this. And also the decimal separator. So this is 300,000, or is it 300 decimal 678? In Brazil, the comma is to separate, is a decimal separator. But in some countries, the comma is a separator for thousands. So this would be 300,000. And for example, in the US, the point is used as a decimal separator. But in Brazil, the point is used to separate thousands. So it's very important to set this standard to know that, no, when I'm writing comma is a decimal separator, and when I'm writing point is a thousand separator. And some general tips is to always avoid using special characters in any text that we import in the database. So after we understood the data, we have the table structure, we have all the standards, we have like all the data standardized, and we want to make now the validation of our data and finally import the data into our database. So it's very important to question is, have all the data been standardized correctly according to the patterns that we established? Are there any duplicate data? Do the data make sense? Because sometimes like, usually my water level is 10, 11, 12, 10, 11, 12, and then I have 1,000 in one day. So probably it's a mistake, so it's very important to get this data to see if it makes sense and before we import the data in the database. And this means quality control. And also we can get some automated processes of data import, and that gives us agility and data quality as well. So this is like, how am I going to import the data? After I have the data in my database, I can finally arrive in the analysis and visualization of our data. Finally get to the business intelligence that we call. So we can have plots like charts, we can have dashboards with our data that's in the database, we can have calculation of some indicators, we have well profiles, we can have maps, we can have cross sections, we can have 3D visualization, and all these visualizations you can have on GeoAnalyst, which I'm going to show you later. So I'm gonna now that we got through all the basics and all the introduction, we're gonna start talking about specifically on GeoAnalyst, which is a very important software for data management. It's the software that we use here in water services to implement integrated database in our clients. And I'm going to show you why we use HGA and why we think HGA is so good to data management. So first of all, HGA allows us to make some integration with other tools. So I have all the data that I have in the database. I can integrate with other softwares, for example, with Power BI, with Excel files. It allows us to do this integration. So it makes it easier to see the data, to analyze the data, to visualize the data and the information. HGA also has some visualization, analysis, and automated reports within the software. So inside HGA, I have these visualization tools like the Map Manager or Query Builder, plots. We have some different tools to analyze, to have the information to analyze the data. HGA also has validation and controls inside it. So before I import some data using HGA, the software checks if the data is has a quality assessment. It checks if the data, if you don't have any duplicate data, if the data that we are trying to import, is it following the standards that we established? Because in HGA, you can tell the database like what are the standards for all the parameters, like, oh, dissolved oxygen is always DO. So if I try to import a table with the parameter written as dissolved oxygen, it won't allow us. It will say, no, you cannot import this data because there's a mistake on the parameter column. And then I'm gonna check and see that I have a typo on the dissolved oxygen. Instead of writing DO, I wrote dissolved oxygen. So it has this validation and control inside it. It doesn't allow us to import data that don't follow the standards that we established. It also has some tools to make it easier to import new data. So it has some data entry automation. You can import data manually, and you can also import data in an automatic way, or also in a way that we call the EDD. And I'm going to show you an example using the EDD file. And usually that's what we use from labs, for example. So if I have many points in my area that we have some monitoring events, and the labs collect the data, analyze it, and then before sending the data to us, to the clients, they use the Quick Checker, which is a software that it's a free software that works with HGA, and we train the labs to use the Quick Checker, and then the labs they have a template format for the database, and they know what's the format of the database. They know how to write all the parameters. They know all the standards. So Quick Checker checks if the Excel file is filled properly with the standards that we established. And if it's okay, the Quick Checker generates an EDD file. And this file, the lab sends to the client, and the client just download the EDD file and import in HGA. And I'm going to demonstrate this later on how it works and how easy it is to import an EDD file with a lot of new information on the database. And the most important thing of HGA is its flexibility, database flexibility. So it's a very flexible tool. It allows us to create any different kind of table that we want in the database. You don't need to be an expert on SQL or any language of computers to build a database or to create a new table, to create a new column on our table. So let's say, I have a simple table for water level, and I want to add a column to write down which person went to the field and made that measurement. Just so I have a column like operator name, or the name of the guy that went there to check the data. And HA makes it very easy for us to add this new column to our table in the database. And this is not something that we can find in other softwares of data management. And this is something very nice, because sometimes our clients want a table for air emissions, a table for biotic data, for water quality, for many different kinds of data. And it's easy. We just go there and use the template manager, create a table, and it's okay, and it's done. And once again, you don't have to be an expert on SQL to do this. And I'm going to show you an example later for you on how good it is to have this flexibility. So also HGA has a lot of, as I told you, it has a lot of tools that helps the user. So it has tools to import the data. You can import data manually or automatically. It has some insight tools for data validation, for data analysis, data visualization, and also database integrated reports. And some, like I'm going to just show you here some of the most important tools of HGA. So it has the query builder, which is a tool to build custom queries using an interface of HGA. So basically, you're going to write a SQL script to get a table of information, but you don't need to know anything about SQL to write this script, because HGA helps you to do this. I'm going to show you again. I'm going to show you later an example of building a new query to get a specific table, and you're going to see how easy it is to build a query on the query builder. So this is the interface, this visualization of the query builder. So I'm going to show you later. Like you just select all the columns that you want on your table, and then you execute the query, and it's going to give you the result that you want. Like all the columns, it's going to give you a table with the results that you need. It also has a well profile tool that shows you well profiles in cross-section editor. So if you have lithology data for your wells, and if you have this data inside the database, you can use the well profile, and then you can see the profile for lithology and water level or anything that you need to see, as long as it is inside the database, imported in the database. And after I have the lithology, we can draw the cross section, and all of this inside HGA. And this cross section you can export and use in your modeling software, for example, ModFlow, Visual ModFlow. We have the map module, which is a built-in GIS, so you can create maps and make some spatial analysis using the data inside your database. So if you have a raster file with the image of the area you're studying, you can put in the map manager, and then you have all the coordinates of your points. You can plot these points in your map, and then if you have water quality data, you can plot this data in the map. Also, you can have potentiometric map because this map module has a tool to make the potentiometric map, and also to see the plume if you have a contamination plume. So it has this interpolation tools built in. And also you can import shapefiles if you have like shapefile for rivers or that you have in your area. You can plot that in the map manager. And there is a scene viewer, which is a 3D visualization interpolation. So if you have like a history of data, of water quality data of your wells, you can make like little movie for the evolution of your contamination plume. And it also allows us to make connections with different programs like Excel file, Power BI, and then you can build. And once you have all the data, like access to all the data in your Excel or Power BI, you have a whole world of possibilities of dashboards, indicators, calculations you need to make. And all of this is going to be connected to the database. And once you import new data to the database, you open your Power BI or Excel file, and the chart will be there updated. The dashboard will be updated automatically. So it's very nice to see how it makes it easier for people who have this tool, how easy it is to get the information that they need. And I'm going to show you also later some examples on reports that you can make once you have an integrated database. And also how it is how it's easy once you import some data. I'm gonna just show an example importing new data on HGA using an EDD file. And you're gonna see it's gonna be very quick to import this file, this EDD, and then you're gonna open the Power BI. I'm gonna show you. We're gonna send you the Power BI link here on the chat. You're gonna open the link again, and you're gonna see the chart updated there because it's connected to the database, so it's automatically you have the charts updated. And before following to the next topic, I want to propose just a quick break, like 15 minutes. Is it okay for you? Like 15 minutes, we come. It's now it's 1:53 EST. So if we come back at 2:10 EST, is it okay? 15 minutes. Okay, so when we come back, I'm going to show you some report possibilities that you can have. There's some reports that we made here in water services for our clients using integrated database. And I'm going to show you some practical examples using HGA. Why is it so good to have an integrated database? Why is it good to use HGA to manage our data? And I'm going to show an example importing new data and then opening again the Power BI so you can see the data updating very quickly. Before going to the break, I'm going to write here in the chat a link to a Power BI report. And then if you want during our break to open it and then play with the filters and everything, just see the Power BI, the dashboard and everything. Feel free to do this. And we're going to work on that report later. Now I'm going to show you some report examples that we have made for some of our clients here in water services. And all these reports that we made, they are all integrated with the database using GeoAnalyst, using HGA. So once we have the data inside the database, like it's a whole universe of possibilities of report that we can build. So it depends on the necessities of our clients. So for example, if we have water quality data, this example here is for water quality. Sorry, it's in Portuguese because it's a report that we made for some clients here in Brazil, but we can have any dashboards. And this was an example using Microsoft Excel. And it's all integrated with the database, and so you can have a dashboard, you can have a time series plot, and all of this connected to the database. So you can have any different kind of charts, you know. So this is a time series plot, and this is a compliance or no compliant analysis of the data that we have. We can have radar charts. All the charts that we have within Excel files, you can build them in your Excel, and everything is going to be connected to the database once you integrate it with HGA. So so all these examples that I showed you, they are from Excel files. And once you import new data in your HGA, these charts are going to be automatically updated. So you only have the job to build the chart once. And once the chart is built, you only have to open the Excel file, and it's going to be updated with the latest data in your database. And this is another example. It's a diagram representing like the rivers and the points of water quality analysis and the results. So you can play with the colors, like red meaning it's above the limit and blue is okay. So you can play with colors, and like you can use your creativity to work within Excel file and with the data that you have. This is an example of a dashboard that we built using Power BI. So again, so you have two different programs, two different softwares, so Excel and Power BI, and each has its
possibilities, its advantages or the disadvantages. And with Power BI, you have a bigger universe of things that you can build, like of dashboards, of charts and indicators. You can work with maps if you have like the coordinates of your points, and you can like play with the colors as well. Oh, you have red meaning something, yellow meaning something else. So you can play with another, many more things using Power BI. And we can see that nowadays, much more each day, like many more clients want to use Power BI instead of Microsoft Excel. And again, the same as Excel files, this is integrated with the database with HGA. So once the client imports new data in the database, the dashboard is going to be updated. And this example here is for water flow and precipitation within a mining company here in Brazil. So you can have time series plot related with a precipitation plot. And this is also, you can see this also in the Power BI link that Jefferson sent you here in the chat. We also built a air emission report for a client here in Brazil. So you can work with water quality, you can work with water flow, you can work with air emissions, and all of this using HGA because of the flexibility of HGA. So you can put many different kinds of data, and you can build this dashboard, these reports using your data, and you can have like the creativity to relate water quality to air emissions if you want. You know, if you have like, oh, I have some points where I monitor air emissions quality, and also I monitor the water quality just beside it, and then I can have like make a relationship with the results. You never know. So once you have the data in your database, we are working with the relational database, so you can relate all this data. Another very interesting report that we built for a client lately was it's a report for monitoring plans. So, for example, these mining companies, they have a very huge net of stations or points that they monitor the water quality. And so every month they have like, I don't know, like 100 or 200 points that where water is collected and analyzed for, let's say, 50 different parameters. So it's 500 analyses every month. And many times the clients, they don't know if the labs are doing it correctly. Like if I plan to collect data from 100 points each month, is the lab collecting data for 100 points? Isn't it missing 1 point or 2? Yes, I could check that using the Excel and using the PDF files or that the lab send me, but this is going to be a job that would take a lot of time, you know, to check like each PDF file or each Excel, or to see, oh, do I have the data for every point? Okay, I have for the 100 points, but do I have, did the lab analyze the 50 parameters that they were supposed to analyze for each point? So you're going to have to check like for each point, the 50 parameters. So this takes a lot of time, and usually always the clients, they didn't have the time to check this, to check if everything was okay. And by the end of the month, when the lab sends the bill for the job, they can't check if everything was made correctly. And it's like, you trust what the lab sent you and you pay for that. And so we built this report and everything within HGA. So we created some tables in the database using HGA to register data for the monitoring plan. So we put in the HGA, I plan for the whole year, each month, 10 analysis for this point, for this and this parameter. So we put all the information for the monitoring plan on HGA. And also on HA, we have the tables for water quality. So once you have the data in your database, you just have to use your creativity. You just have to connect it with the Power BI or Excel file, and then you can make the relationship between this data. So in this report here, we check if everything that the lab is supposed to analyze, if everything is inside the database. So, okay, in January, the lab was supposed to analyze 50 points and 100 parameters. So this report checks if all these 50 points, 100 parameters, if this data is inside the database. If it's not, which data is missing? Oh, it's missing the iron parameter for this specific point. So now the client can just send an email to the lab. Oh, you're missing one analysis here. And sometimes many times the lab did analyze that parameter, but somehow the parameter didn't come in the EDD file. So now it makes it's much more easier for the client to check if everything is being made correctly with this report here. And also they can, another thing is it helps to save money, because sometimes you have so many points and so many different periods of analysis. We checked that sometimes for the same point, the client was paying for the same analysis twice or three times. Because I don't know, like we have in this point, we have some monitoring that we have to make every month, and some parameters they have to be made every 2 months or every semester. And so this report also tells you if you have a duplicity of analysis. Like sometimes you have, oh, I'm analyzing iron for the same point twice for the same date. So you can save money. You can see, oh no, I already analyzed our iron here, so I don't need to analyze again. So, and all of this I'm saying is because once you have this flexibility in the database in HGA, if you have the data, you just have to create a table and put the data inside your database, and then you can build the dashboards and reports that you need. Another very nice example here in water services. In the last 10 months, we've been developing a water balance tool, which is called Visual Water Balance. And this software, this tool is integrated with the database with HGA, and it makes it much more easier for the client, for the users to create a fluxogram or a flowchart for the water balance of the company. So like for a mining company, you have like a lot of different water fluxes or water flows in your operation. So you can easily just add all these flow charts here, and everything is connected to the database. So if you zoom in, you can see like all the volume for each flow. Like for example, here I have this volume of precipitation going inside this dam here. I have this volume of water from rivers going inside the dam. And so we made it much more easier to build this flow charts, and then you can have access more easily to the indicators of water use, and everything connected to the database, to HGA. And this tool that we developed, it has a flow chart, it has maps, it has a dashboard, and also you can have, like for example, if I wanted to see more details specifically for this dam here, you can have like specific flow charts for the dam, and there's this map module with like everything plotted with coordinates, and there's a dashboard with some indicators that the client wants to see more easily. For example, how much water am I using per ton of mineral that I'm producing. So all these indicators they can get from this water balance tool here, and everything connected to the database, to HGA. which also makes it easier to do this, is because the database used by HGA makes it possible to integrate with other systems. So if you have another system using, for example, API system if you have a API system for water flow data, for example, you can integrate with HGA, and then you have automatically every day you have all this new data of water flow or of precipitation every day being updated automatically in the database. And then you are going to see it in the for example in this water balance tool here. And now I'm just going to show you some practical examples I'll talk to you about using HGA. Let me open it here. So this is it, the HGA interface. It has a lot of tools here, a lot of modules. And I'm not going to show you everything here, but if you're interested in learning these different modules, different tools, Waterloo, in partnership with us at Water Services, we're going to be offering a course on HGA next month. So if you're interested, please stay in touch with us and keep looking at our LinkedIn and to see more information about this course. But I'm going to show you just some examples here. So this is the interface. You see here, you're seeing here all the points that I have registered in my database. And if I come here, I can see all the different tables that I have in my database. So I have a table for station registration. I have a table for well history, for TOC history. I have a different table for lithology information. I have a group of tables for well construction, for drilling record, drilling time, casing, screen information. I have a group of table for quality monitoring. So I have a table for parameter sample and another table for parameter result. I have table for hydrogeological monitoring, so for water level, for well operation. I have table for meteorology data and another table for reference standard for compliance analysis, for example. So in this example that I'm showing you here, these are the tables that I have in the database. But as I talked to you before, a very nice advantage of GeoAnalyst of HGA is its flexibility. So let's say that I want to have a table for air emissions now. I want a different table here in my HGA because I don't have any table here to put my data of air emissions that I monitor every day here at my company. So I just have to open the template manager, this tool here of HGA. This is the tool to create new tables, to create new columns on tables that already exist. So for example, we have the quality well construction here, the drilling record. I have all these columns here. Each thing that I'm clicking here, they are different columns. So let's say that I want to add another column in my table here to see what company was responsible to drill the well that I'm registering here. So let's say the field name is going to be company name. And I just click OK. And here I have another field in my table. So that easy. And so let's say now I want to create the table for air emissions. So I'm going to create a new category of tables. And this category is going to be named air emissions. Now I have the category of table. And now I have to create the table. So I'm going to add a new table inside this category. And this new table is going to be named emissions monitoring. You're seeing that I'm using underline here, not spaces, because on table name, you cannot have spaces. So yeah, I'm using underline, but I'm going to show you later how to, but if you want another display name, it's easy to change that. So this new table is going to be inside the category air emissions. I could change the category here if I wanted to, but no, it's a table for air emissions. And now I have to create to tell HGA, so which columns am I going to have in this new table. So let's say the first column, it would be the date that I am analyzing, because I have made a lot of points that I monitor and in different dates. And then each day I monitor some specific parameters. And so the first column is going to be date. And the type of data I'm going to put in this column, string is when it's a text type of column. Integer double is when it's a number. Yes or no is going to allow me just to put yes or no. Date is going to allow me only to put date in this field. Time is going to allow me to put only time. Date and time is date and time. Image is for when it's a field for image. So I'm going to put date and time because sometimes because I want to I have like an exact hour of my monitoring, for example. So you say date and time, and this is going to be a primary key for my table, because for the same station, I cannot have two measurements of the same parameter at the same date. So this is a primary key. And I'm going to have more columns in my table. So the next column is going to be the parameter. It's going to be also a primary key. And what type of data I'm going to put in this column here. It's not a number, because parameter is a text. So it's not a yes or no, it's not a date, it's not a time. So it's a string. So there are two possible strings here on HGA. String 255, this means that I can put 255 characters in this field, but I don't need this many characters. So I'm gonna choose this one here, the custom, and it's gonna tell me, so how many characters you want on this field, the maximum. So let's say for parameter, it's gonna be 15 on maximum, okay. And then another field is gonna be the value of my measurement. And this is not a primary key now. And value is a number, so it's not a text. String, if you want to put numbers in strings, it's okay, you can put, like string is open for anything. But this is a field that's gonna store only numbers, this column here. So it's gonna be integer. Integer is only for integer numbers, so 1, 2, 3, 4, 5. And double is for numbers with decimals. So I'm going to choose double here. And then when it's not a primary key, I can allow it to have null values, or I cannot allow it to have null values. So I'm going to uncheck this box because I don't want any null values for this column here. And one more very important information is the unit of my measurement. Unit is a text, so it's going to be a string, but it's not this long. It's not 200 characters. It's going to be much smaller, let's say 10 characters at maximum. And again, I don't want it to have new values. And one other field, for example, that's very important is comments. Let's say, oh, in this date here, it was raining, and I didn't go I couldn't measure, or the road was closed, or whatever. So I can put any comments here, and we can leave it open for 200 characters. I could write a text here if I want, and I'm gonna set it as allow nulls, because it's not mandatory to fill with any comments. And now I have my table created. So I just hit OK, and here's my table. I just created a new table in the database, and I don't need to know anything about SQL language. Of course, it helps if you know SQL language, if you know all the logic behind the SQL database, but you don't need to be an expert on SQL to work with HGA. You see, it was only just a few buttons that I clicked, and I created a new table. And here, for example, I told you that I was using the underline, but I can change the display name if I want to. So I don't want this underline. I want it with a space and the first letter in capital. And now you're gonna see that the name changes here because I want the display name to be different. I want date, and then parameter, I want the first letter to be in capital again. And let's say that here value, let's say that, oh, I changed my mind. It's not a double, it's integer. So I can change here if I want to. So it's open. I don't need, it's something that we can change whenever we need. And you see this checkbox here, it tells us if this table is going to be visible for the users or not. And if it's checked, it's going to be visible. So for example, the station column here is not visible. I'm going to make it visible because I want the users to see which station am I measuring. And I want the station column to appear in the first column, not in the last one. So I use these arrows here to put the station up here. You see that there are some tables here that are invisible. The users are not able to see them. And to do this, all this that I'm making, you need to have the permission, special permission for the database. And HGA allows you to change the permission for every user. So my user has the permission to create new tables, to edit the database. And you can set some users not to have this permission. So I have this permission here, and I'm gonna close. Now that I created my database, it's gonna ask you to reopen the project. It's gonna reopen it because I changed the database. And now, if I go here to my tables, you see error emissions is here, error emissions. And here are the fields, but of course we don't have any parameter here because it's the first, I just created a table. That's why the table is empty here. If I open another table, you're gonna see that I have the parameters, but for emissions, I don't have anything because I just created the table. And if I had a table to import new data here, I could just import here and all the data would be here. And this was an example using the template manager just to show you how easy it is with HGA to create new tables, like with a very different kind of data, like air emissions, quality, water level, and so on. And another tool very nice from HGA that a lot of users like is the query builder. Because let's say, like when I was showing you the presentation before, on the PowerPoint, like I want information from different tables. So let's say I want a table with the station name, and let's say for water quality, I want like the sample date and only for iron analysis and only for observation wells. I don't want any other kind of wells. So it's just the observation wells. So Query Builder makes it easy for us to do this. So we just have to create a new query here. So let's name it iron, for example. And I just have to tell the tool here which columns I want in the table of the information that I need. So I want the quality monitoring. So I want the sample ID, I want the sample date, and I want the chemical name and the result value and the result unit. But I only want results for iron. So I just put the conditions here for iron. So the parameter has to be equal, and then I choose iron here. And I have one other condition. So I put and, I add here another condition, and the other condition is that it has to be observation well. And where is this information? It's in the registration table. In the registration table, I have a column here called station type. I just put it here, the station type, and I tell HGA that it has to be equal observation well. So I just save it. And when I execute this query here, it's gonna give me as a result a table with the exact columns that I asked HGA, asked the query builder. So I have here the station name, the sample ID, the sample date, the chemical name, which is iron, the result value, and the result unit. So I have here the whole table. And then, okay, but I want to use this table in Excel file. I have to export it. So I'm going to export here as iron information. It's going to ask if I want to open the file. I say yes. And here I have the table. Station name, sample ID, sample date, chemical name, result value, result unit. And now I can work with whatever I want using Excel file. I can build the charts or whatever analysis I need to make. And you saw like how easy it was to build this table here. And on HA, you can also play with filters here. Like you can put like from upside down, like from oldest to newest, or the opposite too. I can filter by some specific point, let's say the OB2. So I have now only OB2. If I export here, it's going to export only OB2, observation well 2. So it makes it easier for us to work with the data. And we're gonna import some new data. And you're gonna see that this query, once I built this query here, it's done, it's here. So every time I execute the query, it's gonna look in the database for all the data that it has. So when I import new data, you're gonna see that it's gonna be with more lines here. Now I have 120 data for iron analysis. You're gonna see that this number is gonna go up because I'm gonna import new data. Because so for now I only have data only up to 2020. And now let's use the Power BI. So this is a Power BI that is linked with this database here. So all this data here is linked with this Power BI. So if I make any changes here, the changes are going to be reflected in the Power BI here. And this is the Power BI. This is the link that Jefferson just sent you on the chat here. So, well, you can play like with this Power BI here. You can go to the dashboard, and then you see different information. Like you can plot here the location of all the points. So you see here all the points here. So this is the HM8, and these are the coordinates, and they're all located in Cambridge. And you can ask, oh, but where is this coordinate coming from? It's coming from the registration table here, the X and Y here, the coordinates, they are here. So Power BI is connected with the database, and that's why I can see all the information here. So I have this compliance analysis, parameter compliance, number of samples per station type, and I can filter for a different date. So I only want to see data for 2018. So I can change here, or I can use this little tool here. And we have different dashboards, so I can have different charts like time series. I can change. Now I'm seeing data from DW100 calcium. If I want to change for iron, just come here and choose and change it. And I can change for another point. And you can see here the upper limit for the compliance analysis to see if in any given time it is over the limit or above or below the limit. I can see the unit here, so I'm seeing iron, milligram per liter, and compliance analysis, water level charts, because I have water level in my database. So I have some water level data here related, and I have a precipitation chart below it. So if I change I can change the days here. So it's going to show me like I have only data from 2021. And there's a general table if you want to work with a table. So I have a table here for hydrochemical analysis and also water level data. So if you see, like, for example, here for the DW one, I have only data until 2020, and my filter here is until today, but I only have data until 2020 for iron. And it makes sense because we just executed this query here and we checked that, in fact, I only have data until 2020. So let's say that I just asked the lab that works for me to send me all the data from 2021 and 2022 in an EDD file, because I want to import this data in my database. I want to update my database. So the lab sent me the EDD file. So let's say here I have the email. They sent me, let's pretend that this is the lab that sent me the EDD file. I just have to save the EDD file in my computer in some folder. And then I go back to HGA and I'm gonna import data. It's an EDD file. I look for the EDD file. I have it here. I just open. And here, it's all this data is imported. 250 new samples and over 3,000 results imported in, I don't know, 2 seconds, close. So now I have new data here. Now I just have to update the data. I just have to update the Power BI just to see, to tell it, oh, hey, Power BI, now I have new data, please update with the database. So I'm just updating it here, and then I'm going to ask you to reopen the link to see the data, like to see the charts updated. And now if we reopen it, the same link, doesn't have to change. If we go it should be updated. So here you can see now I have data until 2022. Let's change for iron. You see, we had only for 2020, and now we have data from 2021 and 2022. So I have this new data here. So it took only, I don't know, a few minutes, 1 minute to have the chart updated. So if I use this chart for some reason to report to my manager or for environmental agency, I have the data here. I just spent 1 minute to ask the lab to send me the EDD file. The lab sent me the EDD. I imported in the database, and now I have it updated here. And with Power BI, like, we have many possibilities, like to see the data differently. Or let's say I want to see like the dates, not only the month. I want to see the date when the data was analyzed, or no, I want to see only the average for the month or the average for the year. So Power BI gives us this possibility, many possibilities to analyze the data. And you see, like, and now we have the data here updated very quickly. And if we execute the query here again, the iron one, you're gonna see that before we only had data for up until 2020, and now we have data until 2022 because we just imported new data in the database, and automatically I could see the new data in this inside HGA and also in the Power BI that we were analyzing. And that's it for today, guys. I left was a little bit quicker than I imagined, but yeah, and I left some time for some questions. If you have any questions, please feel free to ask me. And once again, about everything I did here in HGA, we are gonna teach you in the course that we're gonna give on next month in partnership with Waterloo Hydrogeologic. If you're interested, just please contact us.
Christian, we have a question of Abdullah Lamini. Is in the chat. Do you like that I
when we are
read for you?
making, this is the one when we are making study in order to present in articles, special method to import chart to my article. So if you have like, if your Excel, I don't know if it's your chart. Oh yeah, one very important thing for articles. It's very common when we are working with articles like in universities, many people use the R language, and HGA Plus is integrated with the R console. So if you know how to write in the R language, you can use this tool here to create your charts or whatever analysis you have with the R console, and the analyses are gonna be made with the data imported in your database. But let's say no, I don't use R, I use the Excel files. So if you have an Excel file, you can easily integrate Excel with your database, and you can build, like I showed you in the presentation here, some examples of charts. Let's come back here a little bit. Like this chart here, it could be made, this example here is in Power BI, but it could be on Excel file. So I could have a chart on Excel file that is integrated with the database. And once, let's say I have the chart already in the pattern of my article. Once I import new data in the database, the chart will be updated here too. So I could use this chart here, just copy and paste in the document that I'm writing for the article. And also in HGA, there is a plot module. Okay, there's a plot module here where you can, this one here, this is the plot module where you can plot some charts, specific charts. And if you have HGA Plus, you have all the charts that are also in the Aquacam software. But let's say, no, I don't want the charts that are in HGA. I want the charts in Excel software. So you can integrate Excel with your database. HGA has undo or redo feature. Well, it has here a backup. It allows you to make backup of your database. So it's always good to have, like, I don't know, like every month or every week to have a backup of your database. But once you change something in your database, let's say, oh, I just imported things, right? If I didn't want to import this, I have to erase it. You're gonna have to erase it manually or using a SQL language if you know SQL, but you cannot, like, there is no Control Z, there's no undo or redo. You cannot do that. Or let's say, oh, I'm working here and I don't know, I changed the name here, but I didn't mean to. I just changed the name here. Of this point, it was E22 and now it's 23546. And sometimes it depends on the change you made. HGI only changes it if you save it. So let's say I changed this and didn't save. And let's say I do another thing or go to another, let's say I close this here. It's going to ask me, oh, you have some changes you didn't save. Do you want to save them? And it's going to highlight where it has changed. I'm going to check. I'm going to see, no, I don't want to change. So I didn't change now. But let's say that you change it. Let's say that somehow you erase it, some things that you didn't want to. Let's say here, for example, I come here and I was just looking at the data here and I hit the X and I got scared and I hit yes. Oh, I just erased it, something here, some data here. You cannot undo this, So some things you cannot undo and some things you can undo if you don't save. But so that's why it's always good to be careful with when you are working with database. Also, for example, if I'm working with the template manager, I have this administrator license here, administrator permission, and somehow I erase the whole table here. You lose everything if you erase the whole table. So you need to be careful when you work with your database. Can we import the Aquachem datasheet and treat it using HGA? Yes, HGA has this, if it's in the same pattern as the database, all the columns, all the tables, everything, yes, you can use HGA. And actually HGA Plus has all the features of Aquachem, has all the features. Can we share the HGA database and can the data be open with any software? Yeah, so the HGA database is on SQL Server. So you have the server there, and you can connect it with another software if you have. Like it's not closed only for HGA. You can use it for another software if you want to. Like let's say, oh, I have HGA now, and I have this database, and I have like 10 years of data here, but for some reason I don't want to use HGA anymore, so I'm gonna delete HGA from my computer. But your database is gonna be there in the server. You're not gonna lose your database, and you're gonna be able to open your database using another software. So you're not gonna lose it. So it's not like mandatory connected. You know, you have the server with the database. You have HGA. HGA is just a software to help you manage the server, manage the database, to create a table, to create new data. I don't know if I answered you, but if you have more questions, please just ask again. Can I make a graph on my study area and update the date? You mean like if you have, well, if you, I don't know if I got it right, but if you have a graph on, let's say on the plot module here of HGA, or if you have a graph on Excel file or Power BI, and it's as long as it's connected with the database, yes, once you update your data, the chart will be updated. Just as I showed you here on this graph here, like it's gonna be up as soon as I update, I get new data, the chart will be updated.